Hey guys, today we're going to be learning about chemistry. We're going to do a little bit of an extension from the introduction I did before, back in July. And this is just going to be the basics of chemistry. Okay, so what is chemistry? Chemistry, quite simply, is the study of matter and the changes it undergoes. It referring to matter. So, if we want to understand this definition, we're going to have to know what matter is. So what matter is, matter is just anything that has mass and has volume. So matter has mass and has volume. Fix that. Okay, so volume is the amount of space anything takes up. And if we want to understand the definition of matter, we have to understand what mass is. So let's go ahead and do the definition of mass. Mass is, quite simply, it's a measurement of an amount of stuff. And stuff can be anything. Measurement of, and I'm just going to shorten amount of stuff. Now, stuff can be anything. So, honestly, it can just be any number, because you're measuring stuff, and what mass is that the amount of that is your it's your measurement. Okay. So let's go over some more definitions. Something really important to know is, what is an atom? An atom is the smallest unit of an element that keeps the properties of that element, whichever element the atom is representing. So, for example, let's say we have an atom of oxygen. Oxygen has, let's say, has 8 protons, meaning that an atom of oxygen will also have 8 protons. So, another example with this would be with, let's say, fluorine. Fluorine has 9 protons. So an atom of fluorine would also have 9 protons. Now let's go broader. Let's go with the whole thing. An element. What is an element? I'm just going to stop writing, just make sure to listen. An element is a collection of only one type of atom. So multiples of one atom, like, I can't think of another one for collection, but a collection of one type of atom. So a collection for oxygen, a collection of oxygen atoms, and an element is also a pure substance, meaning it's not mixed in with others. So let's say with fluorine, fluorine is a collection of fluorine atoms. Okay, now let's go on to properties. Properties are just concept. It's another concept. It's just what properties these elements can have. So there's there's two kinds of properties. There's extensive and there's intensive. Intensive. So extensive depends on the amount of stuff present. That was a mistake. Okay. Amount of stuff, or whatever we're measuring. Ran out of space there. Okay, extensive properties depend on the amount of stuff present. So extensive properties would be something like volume or mass. Intensive properties do not depend on the amount of stuff, so not depend on that. So examples of this, intensive properties, would be the boiling or freezing point of an element, or density. So boiling and freezing point and density of things do not depend on the amount of whatever is stuff present. Volume and mass does depend on the amount of stuff present. Now let's go over another concept called changes. There are two kinds of changes that can be done to elements and compounds, which we'll get to later. There's chemical, write that a little bit neater, and there's physical. So chemical changes are basically they're a substance ability to undergo an identity change. So what it is, it's just identity change. Let me just change the color. Identity change. So that means, let's say, an atom of chromium undergoes a chemical change. That means it won't be an atom of chromium anymore. It may be an atom of vanadium or an atom of magnesium. So basically, the identity of whatever is undergoing the change changes, if that makes sense. So some examples of chemical changes. Let me just erase that. Sorry, it's a new software, so I'm not really sure where to go. Where this is experience for both of us. Okay, let's just do that. Okay, we'll do that. Okay, so, and then some examples of chemical changes are color change. So if a solution or like a liquid changes color, that means it is a chemical change. Or another one is flammability. So if something catches on fire, you know it underwent a chemical change. Now let's go over physical changes, which are just as important as chemical changes. Sorry, I don't know what happened there. Physical changes. So what physical changes are is they are properties that we observe without changing a substance identity. So it's basically without identity change. So what we notice without identity change. So some examples of a physical change would be, let's see, Oh, freezing water. Okay, there we go. Freezing water. It's not color change. It just went from a liquid to a solid. So that's something we observe without an identity change. For example, water, H2O, if you freeze it, it will still be H2O. So that is not an identity change. Another example of this would be, another example of physical change would be, let's think, dissolving salt. Salt goes from a solid, and then after you dissolve it, to a liquid. But the chemical formula of salt, which is NaCl, even if you dissolve it, it is still NaCl, meaning it underwent a physical change and not a chemical change. Now we're going to go over a couple more concepts, just a couple more before we end for today. Okay, so let's talk about mixtures. So a mixture is basically, how do I say this? It's the opposite of a pure substance. So let me explain. So there's two kinds of mixtures. There's a homogeneous mixture. I'm just going to abbreviate it. And there's heterogeneous mixtures. And with pure substances, there's the actual element, and there's the compound. So let's go over pure substances first. So there are two kinds of pure substance, as we said earlier. There's an element and a compound. So an element cannot be broken down further. So it is within itself an element. It cannot be broken down. Whereas a compound can be broken down further. So an example of an element would just be O, or O2. An example of a compound would be NaOH, which can be broken down into Na, O, and H. So this cannot be broken down, but this one can be broken down. But they are both pure substances. Let's go over mixtures. So there are two kinds of mixtures. There's homogeneous and there's heterogeneous. So what homogeneous mixtures are, homogeneous mixtures are just the same. They are just, everything in it is the same. They're uniform. So if I were to do a diagram, they would all look like if they would all be triangles. That is what a homogeneous mixture is. A heterogeneous mixture, in comparison, is, I don't know what happened. A mixture, so a different mixture. So everything will be different in it. So it'll be a circle, triangle, square, or whatever that is, square, rectangle, trapezoid, if I can draw one. It will all be mixed. So homogeneous is the same. Heterogeneous is different. It's pretty simple. Now we're just going to go over one more thing before we end. We're going to go over the periodic table of elements. So let me pause the video really quickly just for a second, and I'm just going to pull up a picture and we're going to see a periodic table of elements. Okay, we're back. So I pulled a picture of the periodic table of elements, and I'm just going to talk quickly about periods, groups, and metals, nonmetals, and metalloids, and how to find them. Now, if that sounded like gibberish to you, don't worry, because I'm going to explain it to you right now. So let's talk about periods and groups. Now, what periods are is they are basically anything that goes up and down. So this whole section from hydrogen all the way to francium, I believe, yes, francium, is a period. So everything that looks just like that is a period. So this one's a period, this one's a period, and all of these are periods. So if the vertical ones are periods, then what about the horizontal ones, you're probably thinking? Well, the horizontal ones are called something different. They're called groups. I should probably pick a better color. Groups. So the ones that go left to right, like this one from potassium all the way to krypton, are groups. Don't forget. So up and down, period. Left to right, groups. Okay, now let me just open it up again. Okay. Let me just try and zoom out. Ooh, that's too much. Okay, so let me just pause real quick and pull up a new picture. Okay, sorry for the delay. I just had to find a new picture. Okay, so now we're going to talk about the last thing, which is metals, nonmetals, and metalloids. So in chemistry, we have this thing called the staircase. And what the staircase is, it's everything on this part of the periodic table. That's a bad drawing, but it's okay. So that is what we call the staircase in chemistry. And so why we use the staircase and why it's important to know is that everything on the staircase, like boron, silicon, germanium, arsenic, antimony, tellurium, and astatine, is important to know because those are all metalloids, as you can see on this label. So there are three kinds of terms that you need to know: metalloids, metals, and nonmetals. And they are properties that define things on the periodic table. So everything on the staircase, as I just explained, are metalloids. And everything to the left of the staircase is going to be metals. So everything over here. So everything on the left are all metals. These are all metals. As you can see here, they're all metals. So this whole area are metals. They're not metalloids, but they're metals. So like hydrogen, beryllium, hassium, borium, copper, zinc, nickel, cobalt. All of these are metals because they're on the left of the staircase. So you're probably asking, then what's on the right of the staircase? Well, what's on the right of the staircase is nonmetals. So all of this stuff are all nonmetals. Back there, metals. Color. Non. I should probably use a better color there. And I'm just put NM, non-metals. So if you look here, these are all non-metals, as it says right there. Non-metals are basically just not metals. So all these like carbon, nitrogen, oxygen, fluorine, silicon. Oh my bad, not silicon. Chlorine, bromine, I can't really read it. Iodine. These are all non-metals. And this concept to know left of the staircase, right of the staircase, knowing the staircase, it's really important in chemistry because it, when you're doing tests, doing any work that you need the periodic table for, you need to know properties. It's important to know because not every periodic table will label metals, non-metals, metalloids. So important to know your staircase, know where it goes, and then know everything on the left side is metals and everything on the right side is non-metals. Okay, so that was the last concept I had planned for today. So I just like to say thank you guys so much for watching. I really appreciate it. Make sure to leave a like down below, comment what I should improve on, what you liked about the video, what you got on your test. Yeah, that's about it. Comment what you want me to do next, and yeah, thanks guys. See you guys next time.